First of all, Larry, thank you for joining here today. Appreciate you taking the time out of your day to join Reimagine 2020 and host this workshop. Go ahead and kick this off with an introduction, and we'll take it from there.
Sounds great. Sounds great. Hey guys, my name is Larry Pang. I'm head of business development here at IoTeX. A little background on myself. I grew up in Los Angeles, went to school at MIT where I studied econ and finance, and spent 5 years as a management consultant at Oliver Wyman, working primarily on digital transformation projects before jumping into the blockchain industry. And what got me into the blockchain industry was I did a project with the World Economic Forum on financial inclusion in the payments sector. And we looked at technologies such as M-Pesa and a lot of other different technologies, but one that really stood out was Bitcoin, because it's a brand new way of thinking about something that we've historically done the same for a very long time. When I came across IoTeX, what really resonated with me is I had the same exact feeling about, these guys are doing IoT in a completely different way that makes a lot more sense. So, today I'll share a little bit more about what we do here. So basically today, I want to walk you through an introduction. I'm going to explain first what is the Internet of Things. And then I'm going to walk through a little bit about why blockchain for IoT. And finally, we're going to walk through how to build trusted devices with blockchain and IoT. So starting with a short introduction, of IoTeX. So I wanted to explain what IoTeX is. We have a vision for the Internet of Trusted Things, which is an open network where all humans and machines can interact with guaranteed trust and privacy. We, as a platform, we really focus on enabling trusted data from trusted devices for trusted applications. Our technology stack ranges from blockchain to various IoT middleware to very robust developer tools. So, IoTeX is 100% open source. We have our own roll post consensus mechanism that's 5-second block times and instant finality, very, very fast for IoT. And we built this thing completely from scratch starting 2 years ago. And on June 1st, we're going to be launching our mainnet GA, which is a big milestone for us. On the middleware side, we work a lot with decentralized identity, not just for people, but also for devices. We are dabbling in decentralized storage, working closely with the IPFS team to put a lot of IoT data on decentralized storage. And finally, we have a concept of confidential computing to allow people to own their encrypted data and use it without sacrificing their privacy. And finally, on the dev tool side, we have an edge oracle that brings real world IoT data to the blockchain. We have IoT dashboards that help you visualize your data. And we're investigating some smart contract tools like Truffle to make developing on IoTeX extremely easy. The history of IoTeX, again, we got started in 2017. I made 4 testnet code releases throughout 2018 and 2019. We launched our first product called UCAM earlier this year, which won the CES Innovation Award for cybersecurity and privacy. And finally, as I mentioned, we're going to be launching our mainnet GA just in a couple of weeks. So our vision, as I mentioned, is to create trusted data and trusted devices. But our ultimate goal is to enable these human-machine economies and also privacy-preserving applications. So again, users can enjoy privacy without sacrificing usability, and also trying to enable new human-machine business models to emerge. And before we dive into the specifics about why these kind of 3 pillars are so important in our ultimate vision for the Internet of Trusted Things, let's take 2 big steps back and just talk about what is IoT. IoT is the Internet of Things. You can think about it as the gateway between the physical and the digital worlds. All these devices, over 20 billion projected by 2025, ranging in size, shape, but all of these things kind of have a similar anatomy and similar roles in the entire IoT ecosystem. So, whether it's your headphones that are connected to Bluetooth, virtual assistants, your computers, different types of sensors, your video games, all these things are now internet connected, which add great efficiency and convenience for our lives, but also come with some worries on the security and privacy side, which we'll dive into throughout this presentation. But let's think about what all IoT devices have today. If you break down any type of IoT device, you'll find 4 standard components. One is the sensor, meaning what type of physical phenomena does this device read, right? A camera has a sensor that reads light But there's also other types of sensors, right? Vibration sensors in the form of gyroscopes, temperature sensors, you name it, right? So a lot of different sensors to read physical phenomena and convert it into digital form. A wireless module is how you connect this device to the internet, right? Not all devices use Wi-Fi today. Some of them use other low power wireless connectivity like Bluetooth, like LoRa, and other types of connectivity mechanisms. Cellular is also a big wireless connectivity mechanism. So there are a lot of different wireless ways to move your data from device to server. Your device needs some type of battery or power supply, whether it's a battery that's kind of standalone or a power supply that's plugged into a wall outlet. And finally, devices have different degrees of processing, memory, and storage capabilities, right? If you're talking about a cell phone, which is in itself a connected device, it would have very, very powerful and almost computer-like processing, memory, and storage. But if you're talking about a sensor that is meant to run on 20 years battery life deployed out in the desert, these types of things are very battery draining. So expect to see less of these activities on the device. But this is the typical anatomy of an IoT device. So given this anatomy, let's talk about the typical data lifecycle of an IoT device, right? What does an IoT device actually do? So there's three kind of main components here. One is data acquisition, one is data processing, and one is communications, which kind of uses the different parts of the device that I shared earlier. So I mentioned, sensors today measure physical properties and convert them into digital data. This can be things like your physical location through GPS or even triangulation via cell towers, climate, temperature, humidity, air pressure, motion, vibration. Other sensors, cameras, proximity sensors, smoke sensors, all types of light sensors across the entire UV spectrum, such as infrared, alcohol, smoke, all these types of different sensors are out there. So basically the first step is the sensors on the device will gather the data, right? The next step is to process the data. This is an optional step. So for more powerful devices, they will have the option to do some basic data aggregation, validation, and analytics on the device itself. And the reason that this is important is because the more validation you do, quote unquote, on the edge, meaning on the device itself, that means you have less data to pass and less data to process in the cloud itself, which has a lot of scalability benefits, right? So you're taking raw data from the sensors. If the device is powerful enough, you're doing some on-device processing. And finally, you're getting kind of processed information, turning raw data into information and insights. And finally, once you have this acquired and processed data, you have to get this data from the device to the cloud or to your physical database, right? So a wireless module transmits data to a gateway or directly to the cloud or other storage means via various connectivity methods, right? So Wi-Fi is the connectivity thing that we're most familiar with. It passes large amounts of data at very high speeds, but is very battery draining. So for a lot of different IoT devices, this may not be the best option, but for plugged in devices, you see this as a common way that we power our devices. Other things are called low power wide area networks. We'll review this in a minute. But this basically connects a low power device to a fully powered gateway, which then connects to the cloud via Wi-Fi. So you think about it as like different types of hops that you're taking with different IoT devices. So even putting this further together, right? Let's think about each of these individual devices gathers data, processes, and transmits it to another device. But let's string it all together. So this is kind of what your typical smart home looks like today. Basically, the smart device owner will interact with their devices through a mobile application that's likely run on the cloud today. So cloud-based applications and services interact with your smart devices. Blockchain is a great alternative to run your applications and services in a decentralized fashion. But for the sake of today's Internet of Things, let's talk about it in the context of cloud, right? So basically this cloud is a place where all your data from your smart home eventually goes. But how does it get there? The first step is, this wired Ethernet connection to your modem or your router. Sometimes these things are the same device, but basically it connects your home network and the devices on it to the internet. This is the thing that you're constantly resetting to get Wi-Fi. Sometimes these come in different forms, right? If you need a router to basically expand Wi-Fi to all different parts of your home, you may have multiple routers, right? But it basically creates a a wireless network across your various smart devices that are Wi-Fi powered. But what about those devices that are not Wi-Fi powered, right? You typically need to connect those through something called a smart hub. It syncs different low power devices to your network via these smart home specific connectivity mechanisms. Bluetooth Low Energy is a very popular one, or Z-Wave and Zigbee, which share a lot of the same properties, but one is more proprietary than the other. And just to jump into some other connectivity protocols, as I mentioned, Wi-Fi today uses too much power. There are different types of protocols out there that have different frequencies, data rates, range, power requirements, and costs. When you're thinking about your specific IoT implementation, it's important to think through all these different options you have, try to make it fit for purpose. Thinking about cellular, large data rates as well, not as fast as Wi-Fi, but decently fast with 4G and especially 5G coming out. But the range is several miles, and the power consumption is high, and the cost is also decently high. There's also variants of cellular called cellular IoT bands, which is also a variant of low power wide area networks. These generally have different types of data rates, but all go for several miles. Just like there's a very big variety in IoT devices, there's also a big variety in the types of connectivity protocols that power them. In the Internet of Things, there's a big concept of heterogeneity, right? There's a lot of different types of devices that serve different purposes, but they're more similar than you think. The thing that really restricts these devices from working together is not the technical things under the hood. It's more about the overlays from the device manufacturers that issue them that prevents this interoperability. And we'll go through that very shortly in the next section. So, just to wrap this up, we went through what the typical smart device and smart network looks like today. So here are some common attacks that you should know about, right, on both the device side and the network side. So starting with the device side, these are things that we're very familiar with. Malware, we've been dealing with viruses on our computers for a very long time now. So these are the corrupt applications that can access and share your data. We're starting to see this happening to different types of smart home devices too. So be careful what types of applications you run on your devices themselves. Vulnerability exploits, this is more around direct hacking of your device. Amazon Ring had a lot of these vulnerability exploits at the end of 2019, where hackers just, breached the username and password directly and gained access to the user's cameras and started messing with their kids and all these sorts of weird kind of things, right? But this is another type of vulnerability exploit on the device side. On the network side, this concept of denial of service and distributed denial of service, this is basically flooding a website or a network with traffic. A lot of these devices can actually be bots. Composition of bots is called a botnet. And there's a risk that a botnet can attack your network and just flood it with requests, which makes it unusable. Another big one is man-in-the-middle attacks, right? We see this as an example with Zoom. Zoom, which is now a $50 billion company. They recently were exposed because they mentioned they had full end-to-end encryption, which means there is no man in the middle, but basically they were found out to only have client-server encryption, which means Zoom sat in the middle between the different peers that were trying to video chat, and all of their data was accessible by Zoom in the middle. That is not true end-to-end encryption, and that is the source of man-in-the-middle attacks, where someone with your credentials that you're supposed to trust misuses those and performs a middleman attack. So, now that we have a good understanding of what IoT is, it's all these different heterogeneous devices kind of linked together and collecting data, processing it. So why do we need blockchain? The answer is today's IoT ecosystem, as I mentioned, it's not necessarily the inner workings of the devices that restrict the IoT's growth. It's actually the manufacturers of these devices have chosen not to work with each other, making the IoT ecosystem extremely siloed. So let's walk through this diagram. August is a smart lock company. You probably know Google Nest. They make thermostats and other IoT devices, expanding into cameras these days. And Ring and Amazon, make a variety of smart home devices as well. So, all of these things have their own versions of devices, gateways, their own version of a cloud, and their own applications, none of which can talk to each other for a variety of reasons. One of which is just non-interoperable. The devices that they have are not meant to talk to each other, whether it's at the communications level or is at the device level. But furthermore, there's also competition for data. Whoever has the most data it fuels the businesses of these large tech giants. So there's no incentive for people to share data across clouds or across applications. So quite literally, Ring and Amazon here are saying, you can't sit with us. You can't be part of our ecosystem. And it's very vertically integrated in these different IoT silos. So what does the future look like? The future looks like this. The future will be human-centered and interoperable, meaning all the devices will be able to work together. All the gateways will be able to talk to each other. The clouds, can send data back and forth. And finally, applications will be able to sync with each other. An important distinction also is in this IoT of today, the data owners are actually the corporations themselves. In the future, the data owners will be the people. You may have heard about Web 1.0 and Web 2.0 and Web 3.0. Let me explain a little bit about how the world works today with Web 1.0 and Web 2.0. By comparing and contrasting these realities, we can see the benefits of what we're doing in the blockchain industry, especially for the Internet of Things. Just to start, right, Web 1.0 started decades ago, and these are just the open source standards that really fueled the development of the World Wide Web, the Internet. HTTP, TCP/IP, DNS, domain name systems, all these types of standards that really we take for granted today because they're open source, they're kind of invisible, ingrained into our daily lives, and it's allowed people to build amazing products on top of these open source standards. And that's what Web 2.0 is. More and more these days, you see the internet being dominated by these Web 2.0 giants. These tech giants have proprietary tech stacks. The important thing to know is in this Web 2.0 layer here, this is a box that holds all of the rules, all of the data, all of the value is contained here, and it doesn't trickle back down to the users in any way. There's a great quote that I love. It's that Google built $1 trillion business on top of Web 1.0, but nobody will ever be able to build even $1 billion business on top of Google. And that's because whoever has the data, whoever has the users has the power. And what is locked in this kind of Web 2.0 stack is the ability for anyone else to build on top of it, right? So these are the gatekeepers of the internet. They basically decide who their preferred partners can be. Even, they can kick users out of their ecosystem for questionable reasons. And they can even change the entire rules about how their platforms operate. There was a big fiasco back in the day when Google changed their search engine algorithm. A number of businesses that relied on the old algorithm, but without notice, they dropped the new algorithm and destroyed a lot of businesses out there. So, it's very common and very easy to point the finger and say that Google, Apple, Facebook, and Apple are doing something wrong. I'm not saying that. What they've been able to build on top of Web 1.0 is fascinating, and it's really propelled the world into a better place. But now, as these companies start to enter our homes, where they set up cameras and virtual assistants that literally listen to us 24/7 and watch us 24/7, and they're starting to issue patents that signal they want to control us in our homes 24/7, then it's time to think about other alternatives. And that's exactly what Web 3.0 means. Using the same Web 1.0 standards that operate the internet, what we can do is we can build a decentralized, open source, and permissionless framework that allows people to build on top of this, where the next $1 trillion business will not be restricted by the gatekeepers of the internet, but it will rather be facilitated by IoTeX and other decentralized platforms, ones that governance is managed by users, and all the data and value is captured by users, not corporations or institutions. I can't stress enough the importance of this concept. What we're doing is fundamentally recreating a lot of this capability that we built in the Web 2.0, but making it open and accessible, which is a bet for the future. This brings me to the IoTeX platform. IoTeX is much more than just a blockchain. We've always had the mission of enabling IoT and privacy use cases on our platforms. Basically, what we try to do is generate trusted data and trusted devices and hand that off so that developers and companies don't need to rebuild those capabilities. They can intake that trusted data so that they can fuel their own trusted applications. To walk you through the entire tech stack about what makes these trusted data, devices, and applications possible, it starts with blockchain on the very bottom, right? As the infrastructure layer, the root of trust for the entire network. We get the question a lot about, IoT generates so much data, can blockchain actually handle it? As I mentioned, IoT devices themselves can pre-process a lot of that data. And this is not just, something that is forward-looking. This is happening every single day. It's kind of this edge-oriented architecture. So first of all, the amount of data that needs to be written to the blockchain is not necessarily all the raw data. It's just the triggers, maybe some type of physical phenomena. For example, if you have a temperature tracker and it goes from -1 degree Celsius to 1 degree Celsius, that may be a trigger that, hey, this thing is not below freezing anymore. I need to trigger a smart contract. So only those types of data need to live on the blockchain. The rest of it can be stored on the cloud or on decentralized storage and just hashed to the blockchain for verifiability and data provenance. So that moves from this blockchain infrastructure side, which is fully decentralized, run by 60 plus delegates, including Blockfolio and CoinGecko and other industry names, managing the IoTeX blockchain. But then we get into what makes IoTeX really unique. It's our ability to layer on sophisticated IoT-oriented middleware services that help users manage their trusted data and their trusted devices. Decentralized identity is a core component of trusted devices in the future. Basically, to trust a device, you need to know that the device has a verifiable identity, can discover and be discovered. And also you need to verify that all the actions this device has taken are factual and true. Decentralized storage is also important to make sure that no cloud providers can touch our data, right? All of our data is decentralized, as well as the processing of our data is decentralized. But the storage itself, we're working closely with the IPFS team to build storage for some of our IoT products, such as UCAM. And finally, confidential computing is something we're looking forward to implementing in the future, which is basically the ability for devices to hold encrypted data and process it within a neutral zone. The reason why you trust your iPhone to manage your Face ID and your fingerprints is because it's processed in a special part of the device called secure element. So confidential computing and secure elements on the hardware level enable very privacy preserving computations, which is also a core tenet. Finally, some of the dev tools I reviewed earlier, Edge Oracle to bring trusted real-world IoT data to the blockchain, IoT data dashboards, smart contract tools, etc. So, I think Gino has a question here about what is the definition of the word trust in trusted data, devices, and applications. As far as the word trust goes, it's kind of subjective, right? Whether you trust something or not is ultimately based on what you need to feel peace of mind in working with these companies. In the world of trust today, a lot of that is done at the policy and the regulation level, right? You think about a lot of the consumer data privacy laws out there, like GDPR in Europe and CCPA here in the United States. These are not necessarily things that prevent people from abusing our data, but it does build trust because we have a way to chase after these companies if they do abuse our data, and we can seek financial returns, right? So if they misuse our data, they're going to be fined a very big fine and we'll get kickback off that. But to me, that's not what the end goal should be, right? That's a stopgap solution. We're finding ways that we can build trust as a workaround. What we're talking about here is cryptographically and technologically guaranteed trust. There's a famous saying in the blockchain industry where it's not don't be evil, like urging people, we know that you can break the rules, but please do not be evil. It's not that. It's we are making it so you cannot be evil, right? All these things are fully verifiable, fully traceable, fully transparent, so that there's no way that anyone can abuse our data or even hold our data in the first place, right? It's kind of flipping the model, taking the control away from the Web 2.0, which is a huge black box. And by cracking this open and making it transparent, you can imagine, kind of like you hit a Mario block, all these coins and all these data really fly out and are now distributed. We can have full version of trust where it doesn't have to be subjective, it's fully guaranteed. And that's what we mean at IoTeX when we say trusted data, trusted devices, and trusted applications. This is the IoTeX platform, built it over the past 2 years completely from scratch. And again, it's much more than a blockchain, right? It really requires the concerted effort of devices, connectivity, and backend systems like blockchain. So let's dive right into that. How do we build trusted devices using blockchain and IoT?
So as I mentioned, right, blockchain is a very great tamper-proof backend. But what if we combine it with the concept of tamper-proof hardware? Secure hardware, this concept is used everywhere, but it's very proprietary and it's closed. Everyone knows the concept of open source software, but there's also the concept these days about open source hardware, which is not yet achieved with these special types of tamper-proof hardware. So just take a step back, right? What is tamper-proof hardware? It's basically a special chip. You can kind of consider it to be a neutral zone where you bring encrypted data and code, and basically only within this special environment do you decrypt the data, process the data, and re-encrypt the data and send out the results. So the only time your data is in decrypted form is within this private and trustworthy execution environment. Sometimes they're called secure enclaves, sometimes they're called secure elements, secure chips. To more techie perspective, it's called a trusted execution environment. And it basically guarantees the integrity and confidentiality of all the data and processes run within that special part of the chip, right? Again, this is everywhere today, and you use it almost every day. Your smartphone to manage your biometrics, your credit cards to manage the secure chip, which holds your spending credentials, and your crypto wallet, which uses like Ledger, which uses secure element to manage your private key, right? So the reason why you trust these devices and the reason why they're kind of considered to be trustworthy is because they add this concept of tamper-proof hardware. And as we know, blockchain itself is a piece of tamper-proof software. There's a lot of different qualities that make blockchain very desirable for technology builders. It's secure, decentralized, continuous, meaning it's like a never down network, no single point of failure, and it's programmable, but it's also immutable, meaning if I simultaneously generate a piece of data using my tamper-proof hardware, and I write that data immediately to the blockchain, meaning I timestamp it, what happens is that is a very pure source of data. I know that this data came from a identified and verifiable and tamper-proof piece of hardware, meaning the data itself could be trusted at the time it was generated. And by writing that data immediately to the blockchain, then I know that it hasn't been changed before or after. So this is a piece of data that doesn't even need an intermediary to come in and say, yes, this is trustworthy. You can move on to the next step of your process. Think about any supply chain. The reason why they take so long is there's so many parties involved at every step. If we have this unbiased and trusted third party that is tamper-proof hardware running on tamper-proof software, this really forms the foundation for a lot of exciting automation opportunities. But let's dig in a little bit into this concept in the next slide here. So we have this concept of an edge oracle to bring data from the field to the back end in a reliable way. If you have a tamper-proof piece of hardware, this is our in-house prototyping kit for supply chain, which I'll describe later. It's called Pebble Tracker. This tamper-proof piece of hardware has a trusted execution environment built in. And the role of this device is just to collect, sign, and transmit verifiable data to the IoT cloud or decentralized storage or directly to the blockchain even. This job is to create that trusted data. Once it's created, it needs to be stored somewhere. You can choose to write specific triggers directly to the blockchain and not store any data. That's completely fine too. But most people want to store the raw data so that they can process it on their own, either on the blockchain or on the cloud. The next step here is through some type of wide area network. In this case, Pebble Tracker uses cellular IoT connectivity. You basically send this data directly to some type of storage, right? So the data is stored in the IoT cloud or on IPFS, and it's hashed to the blockchain to timestamp it, right? To give that data provenance and immutability. And after that, we have this very pure source of data. That means it's trusted and verifiable by any party, which means we can automatically plug this into a smart contract. And, as we know, any data that you write to a blockchain is only good if, it can be proven that it was generated in a trustworthy way, right? So by employing this process of tamper-proof hardware and tamper-proof blockchain, we can pump this verifiable data into verifiable smart contracts to generate verifiable results and so on and so forth, right? You see that by starting with verifiable devices to data to applications to ecosystems. This is an end-to-end process, but it all starts at the root. We have this nice blockchain and IoT reference architecture that really walks through all the different details and integration patterns. So this is just a very high-level overview about what we can do with blockchain and IoT. To walk through Pebble Tracker a bit more, right? This is something that we built in partnership with Nordic Semiconductor. They're a very, very large chip manufacturer focusing on radio frequency and cellular powered devices. And basically, they have a system and package that we've built in, and also an open source library that we've kind of collaborated on to add new decentralized tools from IoTeX. To take a step back, Pebble Tracker is a tamper-proof hardware meets tamper-proof blockchain to deliver globally verifiable and trusted data for a variety of use cases, right? Basically, it has cellular connectivity and a variety of sensors, and it has a special trusted execution environment from ARM built in to this Nordic Semiconductor SIP. Again, remember that these devices all have those four components, right? It has some type of connectivity. In this case, it's cellular. It has different types of sensors. In this case, it's location, environment, motion, and light. It has some type of processing, which is baked into the system and package. It has some type of power supply, which in this case is lithium ion, which can last for about 2 to 3 weeks at a time on a single charge. Just to walk through a little bit about the hardware, we use chips and hardware components from Nordic Semiconductor, which is this large system and package you see here. We use a Bosch climate sensor, which does temperature, humidity. TDK is also another famous component manufacturer. They do a great gyroscope, 6-axis gyroscope accelerometer to track orientation, speed, and whether this device is moving. And finally, PMT, which has the light sensor. Also has a lot of other connectors, pins, card slots, and it has a SIM card slot. So any cellular SIM card can be plugged directly into this device, and it can be connected to the internet just like that. Just to walk through, what sensors does Pebble Tracker have and why? We tried to design Pebble Tracker to be suitable for any type of asset tracking scenario. If you think about it, going here, right, what types of data does Pebble Tracker collect, right? It has a location sensor, and this gives you real-time GPS coordinates. It has a climate sensor, has a temperature reading, humidity reading, pressure reading, gas reading. It has a motion sensor, a movement sensor, which can tell you vibration, shock, orientation. And finally, it has a light sensor that gives you ambient light reading. These all seem like interesting things, but what can we really do with this information, right? Let's put it in some real world examples here. So for location, obviously, having the ability to tell where an asset is at a specific point in time is great for supply chain, right? If I have a verifiable source that the person delivering my package is going to be here or is within a 5-mile radius of me, then I can plan my next step, or even a 50-mile radius or a 500-mile radius, right? Really lubricate that supply chain and make it work more seamlessly. And also for last mile delivery, this is great because you can tell if you have a very important package, very valuable good, then you can tell real time where exactly this delivery is. You can also set up, by pumping in this real time location data, you can create special smart contracts that are basically location-based permissions and workflows. We have a team out in London that's working with us. They're called London Blockchain Labs. They basically built a proof of concept called Hyperware, and they use location-based permissions, basically created a concept where every vehicle will have a Pebble Tracker in it. And based on your GPS location, they can charge you different tolls. For example, London has this concept of a congestion zone. If you drive into the downtown area, they'll take a picture of your license plate before and after you leave and calculate the delta and bill you via some type of check or some type of manual process. But what they created is a decentralized way to use this verifiable data to automatically bill you based on how much time you spent within that polygon, that geofenced area. So this is just an example of what location data can be used for, right? Another important thing is climate, right? All these things are very important as far as the safekeeping of goods, the shipping environment, providing transparency for shipping vaccines, perishable goods, livestock, etc. You know, there's a crazy statistic that a third of all food that's generated on this earth is literally thrown away or not consumed, right? A lot of that has to do with the shipping environment transparency, right? We aren't able to tell, you know, if food is, you know, being miskept. You can pump this data into some type of insurance smart contracts to say that, you know, if I ship my fish from Japan to the United States, it's a very expensive piece of tuna, you know, I need this to be held below 0 degrees, right? And if it's held between 0 and 5 degrees, I'm going to issue a light penalty, right? Depending on how much time it's spent in that range. If it ever gets over 5 degrees Celsius, then, you know, I'm going to get my full refund and damages back. And that can all be pre-programmed into a smart contract. Same thing for humidity, same thing for gas, same thing for pressure, right? The great thing is also you can combine these metrics, right? You can say if my location is, you know, within California, and if my climate is below 0 degrees, then trigger this action. If not, continue business as usual, right? So there's a lot of ways to intersect this data very simply. The way I like to describe it is you're creating multi-party custom service level agreements that you can define and tailor yourself in a decentralized fashion, right? Another thing here is on the movement side. So, you know, what can we use movement data for, right? If you think about if you're shipping something very sensitive, like a case of wine, or even like a glass table, right? You need to make sure that the orientation of this object is never flipped to the wrong side. You can make sure that, you know, the vibration is never too large that it could damage the goods. You know, dispute resolution, you know, if this item that you're shipping has touched the hands of 5 to 6 people, all you know as the receiver is the package that it came to you broken, you know, who's responsible for paying for this, right? By having this data verifiable and immutable and unchangeable, you can pinpoint exactly who's responsible for these damaged goods, or at least have data to make more informed decisions. And finally, light, you know, this is an interesting one, right? A lot of the times we get requests from customers is they want to know whether or not their package was open, right? Has someone been snooping in my package? And a great way to tell this is you close your package, you put a Pebble Tracker in it, and if there's any type of light reading before you get your final package, then it's been open, right? And you know exactly who had that package at the time, so you can pinpoint who was at fault. Also, for things like film or light sensitive objects, you can make sure that they were delivered with the utmost care. So basically what we're saying here is not just gathering this data in its raw form, but also managing the entire life cycle for IoT, right? Collecting the data in transit, meaning from point A to point B, data at rest, meaning being stored on the cloud or decentralized storage, processing either on layer 2 or on layer 1 of our platform, and then data retention. You know, this is more about the insights that are generated from this raw data and these processes I described here. So, you know, trusted data from a tamper-proof device like Pebble Tracker can be hashed to the blockchain, and its individual data points, these triggers, can be injected into smart contracts to fuel different automation of service level agreements and business processes, right? It can even be for your daily life, right? You can write your own smart contract and really program your own smart home in a way that recognizes only your data. And, you know, there's a lot of flexibility to be had. It really goes back to this Web 3.0 model, right? If you remove all the dependencies and you remove all the barriers to entry and create a very free-flowing system where any device can be serviced by any service provider and any service provider can service any device, then you remove all the barriers to entry and really allow people to build and control their own futures, right? Both from the builder and the user side. Some other things that you can build with Pebble Tracker, you know, these custom service level agreements, as I mentioned, ongoing POCs that IoTeX is working on with different enterprises here is to track high value goods and auto enforce penalties based on whatever metrics matter to them: location, temperature, etc. Location-based permissions, this is also something we talked about. Automatic billing for vehicles going into and out of the congestion zone. You can check that out at hyperaware.io. You know, another one that we've had lots of interesting discussions around is tracking of people and livestock, right? We chatted with a company about this about 2 months ago in the context of Corona and tracking sick patients. Here in the US, I don't think that will ever be accepted as something of the norm. But in other countries, you see this being used and being used effectively, right? So we've actually had a lot of conversations about how do we track sick animals to identify which other animals they've touched, right? Like, for example, a cow. Mad cow disease is real. Being able to trace sick cows and having that data verifiable and usable is very important for this industry. And finally, remote environment tracking, right? Tamper-proof climate data. If you have different Pebble trackers deployed in Yosemite National Park, make sure it never, a lot of these devices can run on, battery life of many, many years, right? Or the identification of forest fires in high-risk areas, mudslides, all these different types of sensors, right? Any type of physical phenomena can be read by a device today. It's just a matter of how we choose to use it, right? So with that, I'd like to, close by letting you guys know that, IoTeX, as I mentioned, we're launching our mainnet GA, which is our biggest milestone yet. We've been building this thing from scratch for the better half of 2 years now, 2.5 years, and we're finally ready to welcome the world to build on our platform. A lot of the things that we've done at IoTeX, specifically around Pebble Tracker and around other devices that we work with called UCam. Definitely check out UCam. It's a fully private home security camera meant for consumers, not for developers. We would love to welcome the audience here today and anyone watching to build with IoTeX. We have a great new grant program, but what we're really excited about is this concept of an open-ended proposal. So if you have an idea about something that you want to build on Pebble Tracker or just on IoTeX itself, Pebble Tracker, we're planning to distribute the first 50 or 100 or so just to a core group to really make sure we have the first set of use cases and the first set of developers that really help each other out. So basically, we would love for you to get in touch with us. Check out the Halo program at halo.iotex.io. But this is just a start for IoTeX, right? I think after going through this presentation, I want to go all the way back to where we're headed as a platform, right? So this is where we are today. We're starting to see the first trusted devices being powered by the IoTeX network, and it's already allowing users to own and control their devices and data. The next step, after users own their encrypted data, is we want them to be able to use their encrypted data, not just keep it dormant without sacrificing their privacy, right? Usability and privacy. And this has to do with that concept of confidential computing and trusted execution environments, right? Processing that data within areas that we know to be neutral and trusted. And finally, once we have that, once we have a nice collection of these privacy preserving dApps, we'll really start to see small human machine economies, whether it's to facilitate the sharing economy or all different types of use cases emerge. And that's what we call the Internet of Trusted Things. After mainnet GA, this is really going to be IoTex's focus to build not only the infrastructure to enable this, but to work directly with the early adopters and the early pioneers that share the same vision for a privacy preserving IoT as us. And together we can build the Internet of Trusted Things. So with that, that's my presentation for today. I'm happy to stay on to answer any questions that you have, but feel free to check out more about IoTeX on our website, iotex.io, on our Twitter, our Telegram, our Reddit. And you can also email me directly at larry@iotex.io. I hope you enjoyed the presentation. Definitely look out for more great things from IoTeX in the future. As I mentioned, our mainnet GA is coming out in just 2 weeks, and we have a very action-packed 2020 coming for everyone soon. So yeah, with that, I'll pass it back to Adam, maybe just to facilitate some Q&A. But thank you everyone for joining so much.
I have a question. So it seems like, there's a lot of blockchains out there, blockchain companies and teams. It seems like IoTeX is taking it further by including a lot of the middleware and the hardware. Is that accurate to say? Not only just the software, but secure devices, right?
Right. At the end of the day, what we're trying to do is really build full stack solutions, right? It's not our intent to really, take it from end to end as we've done for our initial sets of products, right? I didn't talk about UCAM much in this presentation today, but UCAM has been a very big project for us over the past 6 to 9 months, right? Basically, we worked with this large security camera manufacturer called Tenvis, and they've sold millions of cameras to government, to enterprise, to consumers. They're currently Amazon's choice for security cameras right now. But they came to us looking for privacy, right? But they had no idea how to really build the integrations from blockchain to their devices. They just came to us saying, we want to use our hardware with your firmware and software. And we took on that challenge because we knew that by doing this, not only will we have a product that we can put into people's hands that has great user experience, like we just got some amazing feedback from our community regarding UCAM, so definitely check it out. But it's also about, teaching yourself how to build this, right? If we have to work with companies that come to us saying, hey, I want to integrate my IoT device to the blockchain, and I want my users to own their data, and I want to do these privacy preserving things, then who are we to advise them if we've never done it ourselves before, right? So now that we've gone through the very difficult part of this first integration, the second and the third, which we're already working on with different manufacturers, is going to be much easier. And like I said, all of these IoT devices out there, even though they collect different types of data and the application layer looks different, at the core of it, these are all just sensors, modules, processors, chips that, once we figure out and, cover the bases about, I guess the different categories of different like permutations of options, then we'll have a very plug and play ecosystem, right? And that's really what we want, is for a manufacturer, even ones that, launch products that run on cloud, if they want to come to us and say, hey, I want to launch a Ring camera in the future, powered by IoTeX, we would love to do that, right? But, we're not a camera company. We don't intend to, focus only on cameras. We want to be the enablers of people. And what that really requires is not just a blockchain. It also requires all these middleware, these IoT webhooks, all these things that we've learned from firsthand experience building it ourselves. And now we can offer it to others to build for themselves as well. Yeah, and with that, I think we can call it a day for this workshop. Really enjoyed it. Thank you so much, Adam and the Mousebelt team, for setting it up. If there's any students out there or developers out there that are interested in building on Pebble, please reach out. And we're going to be working with Mousebelt to hopefully put this device in the hands of university students all over the country and the world. So expect to see some awesome hackathons and developer contests sprouting from this. And we'll be happy to share our insights and guide you through the process of building trusted devices with blockchain and IoT.
Awesome. Thank you for that, Larry. Appreciate you taking the time out of your day to join us here. And everybody else, appreciate you tuning in. And we'll go ahead and record this. So this should be viewable sometime in the next 24 hours. All right, everybody. Thank you so much. And thank you for visiting REIMAGINE 2020. This is IoTeX and Larry Peng from Senior Business Development. All right. Thank you, guys. Bye now.